space the final frontier? No, seriously. I'm Leanne Williams, and in today's episode, we try to understand more about the field of astrophysics. Let's take a look at what people in that field are getting up to.
My name is Lindsay Magnus. I'm a researcher here at the Magnetic Observatory. We're based in Hermanus. The Magnetic Observatory has been in Hermanus since 1942. The Magnetic Observatory's main function is to observe and measure and monitor the Earth's magnetic field. One finds that the Earth's magnetic field changes according to various timescales. You get very fast or rapid changes to the Earth's magnetic field, and these are usually driven by changes in the Earth's space environment. And that's what makes us a space facility, is we try and match the observations that we see on the ground to the kinds of changes that are being observed or that are happening out in the space environment. The space environment is often driven by changes to the sun. Now, when we look at the sun, we tend to think of it as just a static, glowing orb in the sky. But actually, there's a lot more going on than just giving off light. The sun changes according to various time scales. The most dominant time variation or change to the sun we see as a pattern every 11 years. Every 11 years, we see a peak or an increase in the activity from the sun. We're talking about the levels of radiation that come off the sun, the amount of matter or plasma that is given off by the sun. All of these changes effectively influence what is going on in our local space environment, and that eventually changes what we see in the Earth's magnetic field. We also observe internal changes to the Earth's magnetic field. Now we must just take a step back and think about how the Earth's magnetic field is created. When we think of magnetic fields, I think the simplest image we have in our mind is a simple north-south bar magnet. And we can get an image in our mind of the magnetic field lines. These are almost like donut-shaped lines that belong to the magnetic field. Now the Earth has a very similar donut-shaped magnetic field. We call this a dipole magnetic field. And in the absence of the sun, the Earth's magnetic field would look very much like the magnetic field of a bar magnet. Hermanus Magnetic Observatory operates a number of locations where we make our measurements. We have a suite of instruments around South Africa, but we're also involved in the South African National Antarctic Program. What this means is we now have instrumentation installed on our two subantarctic islands. So this is Goch Island in the South Atlantic and Marion Island, south of the African continent, as well as at the Antarctic Research Station, the South African Antarctic Research Station, Sanai, in the Antarctic. The reason we want to put instruments further south is the magnetic field that these instruments observe is the magnetic field that stretches furthest out into space. So if you want to get a direct snapshot of what's going on further out in space, then you want to be as close to the pole as possible. And we're very lucky in that we are able to place our instrumentation at these locations and get a good snapshot of what's going on furthest out into space because we're closer to the pole. So what we've got here is we've got effectively what you would see if you looked at the sun. And the most significant thing that you'll see, first of all, are these dark areas that you see on the sun here. And these are referred to as sunspots. They actually indicate a more active sun. And so the more sunspots that you'll see on the surface of the sun, it's indicative of more activity or more energy that is being radiated away from the sun. So what we're going to do is we take this as what we would see with normal white light, and now we put it into a filter. And specifically here, we're filtering at 304 angstroms. What that does is gives us a totally different view of what's going on in the sun. And what's happening here is part of the sun is linked up with a magnetic field and is being transported up into space. If that magnetic field breaks, then that prominence, all that matter that is associated with that prominence can suddenly now move away from the sun and move through space. And that's what we refer to as a coronal mass ejection. All that stuff just gets blown away and moves towards the Earth. The dark and light represent magnetic fields towards the sun or away from sun. And if we take that and we put it into a mathematical model with our images, we're able to arrive at this image over here, which is a superposition of pictures of the sun and a model of what the sun's magnetic field looks like. And why is that important to us? Because these loops that you see, these magnetic field loops, effectively hold the sun and hold the plasma trapped to the sun. If these magnetic loops break, or if there are no magnetic loops over here, then it means that that part of the sun can move away from the sun and move towards us. And if these areas were pointed directly towards us and these loops broke, then that plasma would move through space straight towards us and cause disruptions to our local space environment. These top two screens show us the X-ray count measured in space. Now, the X-ray count is useful to us because it tells us whether or not there has been a solar flare or an event happening on the sun. And we have two different timescales here. We have here, this is what the X-ray count was for a couple of days ago, and then here we have what is the X-ray count for the past couple of hours. If we see a sudden spike in the X-ray count now, we know that something significant has happened on the sun. And then we monitor these satellites over here, which are telling us what the solar wind is like. And what we can expect is that at some time in the next few days, we'll see a sudden increase in velocity and density of the plasma, of the stuff that's connected to the sun that is now moving through space and eventually arriving back at us here on the Earth. And then once all of that happens, eventually these graphs over here, which are the real-time measurements of our Earth's magnetic field, that's telling us what the magnetic field is like here in Hermanus, and this is telling us what the magnetic field is like at our research station in the Antarctic. We'll see sudden changes to these graphs because of the disruptions from the matter that has moved through space.
With us in studio today, we have two guests who are studying in the very exciting field of astrophysics, and they are Moses and Zolile. Welcome to the show today, guys. Moses, can you tell us more about yourself and what you're involved in?
I'm Moses Mkhotsi, born in Betani in the Northeast Province. I studied at Rhodes University, my undergrad, and now I'm at UCT studying astrophysics, doing a master's, and I study galaxies. That's pretty much my research.
Very exciting. Can you tell us why you decided to go into the field of science?
As a child, I've always had a fascination, and I've always wanted to know how things around me and in the universe work. And science is the one way in which we can explain how things around us work, or at least we try to explain how things around us work. And therefore, I've always had this fascination and this interest in science ever since then.
So it's not after you watch Star Trek or anything like that?
No, not really, actually.
Okay, and why specifically the field of astrophysics?
Well, astrophysics means studying things sort of outside our planet. And these are things that we can't go and visit and things that we don't really know much about. And this is the frontier of science. This tests our knowledge all the time, and it's the most exciting thing, I think, ever. So.
Now, we've heard about black holes. Can you tell us more about that?
Yeah. Black holes are basically what happens when a star dies. Well, some stars die. And the thing about black holes is we don't know much about what happens inside a black hole. The tests of physics breaks down, actually, and physics, at least that we know, breaks down at a black hole. And so it's one of those things that people have been trying to understand and make sense of for a long while. Yeah. And it's just one of those fascinating and interesting objects that, yeah, we know about.
Wow, we're going to continue more than that. But Zolile, welcome to the show as well. Now, you're a student in astrophysics. You're not a rugby player or bodybuilder or anything like that.
At the moment, I'm a student.
Okay, wonderful. Do you want to introduce yourself and tell us more about yourself?
I'm Zolile Mkuta. I'm from Port Elizabeth, Epai. And I studied at the University of Fort Hare before I moved over to the University of Cape Town to actually go and do astrophysics.
Now, why is the field of astrophysics such an exciting one?
We learn a lot about things that don't necessarily show up on Earth. For instance, if you look at the makeup of Earth, you would assume that most of the world out there, most of the universe, is made of solid, or maybe you think it's gas, but it turns out, by us looking out there, we find that the most prevalent state of matter is plasma. So by looking at such, we find that we understand things that we are trying to do here on Earth a little better.
Okay, and you mentioned a few things, and Moses mentioned about black holes. How do these elements help us, and studying these elements help us here on Earth?
On the one hand, once we understand plasmas, for instance, which happen which are prevalent in space, right? Processes like nuclear fusion, right? There is a tool called the tokamak, which people are trying to create cleaner energy using plasmas as well as magnets. Those processes are seen largely, they happen naturally in the universe, and by us observing that, we get a sense of what you can expect a plasma in an enclosed space to behave like. And another case would be by doing these studies, we develop tools which might end up being used on Earth for very successfully. For instance, the GPS is based on, the accuracy of the GPS is based on Einstein's relativity. Something else that is based on Einstein's thoughts is the CCD, which we find in our cameras. And that CCD was generally used by astronomers to try and make better pictures of the universe out there. And now we're using it every day, and we actually find that it is a better way of taking pictures and keeping memories forever.
Yeah. Well, this is incredibly exciting, but what do you find is the response of people when you tell them about your studies or your career?
Well, some people just are excited about the fact that they know somebody who does this, and some people ask me about God, which is a little uncomfortable. And some people just go, oh man, that's cool, and that's that. So the response is very varied.
Okay. And are there any particular projects of interest that you're working on at the moment?
I'm currently finishing off an MSc, and I was working on simulating what happens within a star, and using techniques that were developed to actually study our sun. Now, we know a lot about our sun, right? Astronomers know a lot about our sun. A field called helioseismology works on that. We know more about the sun than generally people know about boiling water. And we are trying to stretch that to actually study other stars, which would be able to tell us about processes like this, such as the formation of the black hole. How can we predict when a black hole is going to form?
Very interesting. Moses, welcome back. When we think of scientists, it seems like a very isolated career. Is that so, or do you work in a team as well?
Not really that isolated. Like, as an example, the project I'm doing deals with looking at atomic hydrogen, which is the most common atom in the universe. And there are lots of people around the world also doing that, because it's the one thing we can use to look at the universe in detail and what structures are out there. And I'm involved, at least my project involves working with a supervisor who's part of a group. And that group doesn't only mean people in South Africa, it means people in other countries as well in the world. And so all of these people working in not necessarily one thing, but related things. And every now and again, these people, for example, meet and sort of discuss what they've been doing. And so astronomy, astrophysics at least, is a community of people. And there are lots of people involved. You don't have to work alone. And it's in fact encouraged that you work with other people.
That's good.
Because then you get exposure to other countries, cultures, and also other people. And that's always like a great thing.
That's great. So Lile, because stars are only visible at night, does that mean that you can't work during the day? You're
always working.
Okay.
Always. There are certain forms of astronomy where you look at the radio emissions, for instance, and you can see those during the day. And incidentally, the reason why we can't look at stars during the day is because we are blinded by the light from the sun. Right. So when we're dealing with radio sources and as well as X-ray astronomy, we can work during the day and all the time.
And what job opportunities are available to students who have completed a degree in astrophysics?
Worldwide, it is considered that about 10% of the people who graduate in astronomy end up working as astronomers. Now, that's a double-edged sword because people might think that I might end up not having a career. In South Africa right now, astronomy is experiencing a boom. The government is investing a lot of money into it. But also you find that having learned how to do research, how to look at a problem and try and find a solution, how to model problems, you learn skills that are not available from other people. And therefore, places like banks, science institutes, lecturing, and really having your own business where you do consulting and you help people solve difficult problems, those become open to you.
Okay. Moses, what are, or maybe give us one of the most exciting experiences that you've had so far?
Definitely going to Sutherland so far.
Okay.
That is, it's for those of you that don't know, that's the site where South Africa has a lot of telescopes set up and built. And going there for me and seeing all these telescopes and seeing this beautiful, because when you're we live in Cape Town right now, and when you look outside at night, the city lights, and you don't really see that many stars. But when you go to a remote location like that, where astronomers actually do work, and you look up and you just see how amazing and how quiet and how beautiful it is. That is one of the most amazing experiences I think anyone can have. Yeah. So that's definitely there as one of the best experiences I've had. And I mean, also doing the project that I'm doing now, it's the most fun I've actually had. So that's also
really great.
Really exciting.
I want to know from the both of you, what is the day in your life like? Maybe you can just describe to us your activities, the things you enjoy doing. So Lile, we can start with you.
There's tea at 10 o'clock.
Okay.
I don't miss that.
Okay.
Unless I'm sick. And before then, I come in at between 8 and 9. And a lot of what I do is to find out what other people researching the area that I'm in have found out, right? And learning to make sense of that, which only happens through working and actually understanding the terminology that they use. And then I work a lot with computers. To do models, you actually write a computer code, which is like computer software. And then you socialize a lot.
Okay, that's good. And you, Moses?
10 o'clock tea is obviously a highlight. But in terms of work every day, I get a lot of data on people have made observations. And there's actually so much data out there you wouldn't believe, and a lot of it, people haven't actually done anything on it. So, for example, stuff I do is I look at that data, try and fit certain models to the data, figure out sort of what's happening in the data and explaining certain things that I'm seeing because of that analysis. So basically I analyze data, and that's pretty much what I do most of the day. Okay. And I mean, people probably say astronomers are boring people, but I mean, after that, I mean, there's time for sports, there's things, I mean, I play ultimate frisbee and things like that. And so it's not just, me sitting in front of a computer all day, it's a lot of your day, but it's also exciting trying to figure stuff out, because a lot of the day is problem solving and what am I doing wrong, where am I doing this correct? So there's a lot of that involved. That's
awesome. And for the learners that are watching currently, what are the most important subjects that they need to choose at school in order to go into the field of astrophysics?
Definitely you want to do maths and physics, because I know a lot of people think it's hard, but it's actually, if you put in a bit of effort and work, you realize it's actually not that bad. And it's amazing when you come through what I've gone through universities to realize that maths is at the core of a lot of things that you do. You can't run away from it. You can try, but it's to your benefit that you don't. And physics is also, I mean, it's a cornerstone of how we understand things around us. And so even if you're not necessarily doing astrophysics, I would suggest people do that, because it helps you understand at least what we understand of the world. And I mean, apart from that, you can do other science studies. I mean, I did biology and things like that. And even through university, I did stuff related to that. So there's so many, what people don't realize is astronomy isn't just, physics and maths as well. There's things like astrochemistry, there's astrobiology. There's so many things that don't just involve maths and physics. So the sky's the limit in a sense. But the main important things are definitely physics and maths that you should do.
That's great. Awesome. Zolile, how can South Africa benefit from the field of astrophysics?
Primarily, if we look at the importance of having people who are able to solve problems that they are facing, given the information that lies in front of them, that is a skill that you can use in everything that you do. So from a skills perspective, it's invaluable. And in the case of astrophysics in South Africa, one of the things that happens is that there's skills transfer. Right? For instance, Mo was talking about astrophysics being a collaborative effort. I am having a supervisor right now, and I will have a supervisor for a PhD. And when I'm older, I'm going to have my own students to supervise. And that's building a skills base that even if I go overseas and come back, I bring in something that is going to be disseminated amongst the people. And then there are also, lessons that the observatory gives out. And even observatories in Joburg and Free State also do outreach work, which helps the public benefit a lot from what we do and the things that we do find out.
Okay, wonderful. And just to end off with, Moses, is there any advice that you can give our viewers who are looking to go into a career in astrophysics?
Follow your dreams, really. I mean, your passions, because in a lot of cases, a lot of scenarios, you have people who, you're interested in that, but your parents and so says you should do that because, you're not going to find a job where. My advice is, especially things like astronomy, it's booming in South Africa. Things like Meerkat are being built right now, and things like the SK could be coming. And that means that we need a lot of astronomers from South Africa who know about astronomy to help run these things. Because currently we don't have that many South African astronomers doing work on, for example, things like salt and stuff like that. And so it would be great to have South Africans actually being more involved in these projects. And so I would say, follow your dreams and work hard, because getting here is not easy. So those are the two things. Stick to your passion, work hard.
Follow your dreams.
Yeah.
Awesome. Thank you so much for joining us, Moses Zolile.
Thank you.
It was incredibly fascinating, and we hope to see more of you very, very soon.
Thank you.
Thank you.
It's amazing to see that some people are pondering about things outside of our horizon. It's inspired me to use my thoughts more constructively. Till next time, take care.